So what is function? In this video, we're going to discuss it, and this is the only video you need to really understand what is function. So before we talk symbols and graphs, let me start with something real that you will understand. Imagine an ice cream shop where every ice cream costs $2. So one ice cream equals $2. So if I buy two ice creams, how much will I pay? So let's put this in a table. So ice cream and the cost. Okay, so one ice cream, I will pay $2. And can you guess how much would I pay for two ice creams? So if you guessed 4, that will be correct. And so for 3 ice creams, I will pay 3 times 2 will be 6. All right, so here you can go on forever and you can guess if I wanted to buy 100 ice creams, how much would I pay? Everything is predictable. Each number of ice creams gives one clear price because the price is already set. It's $2. That's what a function feels like. Before I explain more, I want you to think about that when we talk about how many ice creams, how do we approach this mathematically? What term do we use? So how many ice creams will be our input? And what is the cost of that input will be our output. So those are the mathematical terms that we're going to be dealing throughout this video. Input, which will be how many ice creams, and then the cost will be the output, which will be kind of the result. Notice something important here. I don't have to guess the price. The price follows a rule. If I know the number of ice creams, the cost is already decided. There is no debate. There's no maybe it's this, maybe it's that. That's exactly how function works in math. A function is not about ice cream. It's all about consistency. Every input must lead one predictable output. Input 1, that will be 1 ice cream, gives $2. Input 2, that will be 2 ice creams, will give me $4. And input 3 will always give me $6. And let's say input 100 will give me $200. Let's say if I was buying 100 ice cream. And that is what function is. But let's look at another example. Okay, so when you look at this table, what do you notice? You would notice that row 2, I am buying 2 ice creams, right? And paying $4. And then row 3, I'm buying 2 ice creams and paying $3. Can that be true in real life? So of course not. You cannot buy the same 2 ice creams and somehow pay 2 different prices. That's exact moment we say that this is not a function because there's no predictability in price, and we cannot have one input, right? 2 ice creams have 2 different outputs, basically paying $4 and $3. So here's the rule in normal language. Function equals 1 input and 1 output. Basically, every input will have 1 output. And what does that mean? One number of ice cream will be my input. Let's say if I'm going to the ice cream shop and asking, may I have 1 ice cream? Then I would be paying only 1 price. I can't be paying for the same ice cream 2 different prices. So one input will have 1 output, as in the cost of the ice cream. In math, we don't talk about ice creams, right? We will have a different type of things that we'll say. So instead of ice cream, how many ice cream, I would say X. And instead of the cost of the ice cream, we will say it is Y. So then our X will be our input, because we're saying how many, and then our Y will be our output. What was the result of how many? In here, we said ice cream and the cost. So as you can see from this table, if the rule is multiplied by 2, that means that every input, every x, will have only one output, as you can see here, 3 and 6. But this table in here will break the rule. Input 2 gives 2 output, so that is not a function. Now, mathematicians needed a short way to talk about outputs. Instead of writing the output when the input is 3 every single time, they invented a symbol, which will be f of x. Now, f of x does not mean multiply. It does not mean f times x. It literally means the output that goes with the input x. So x is still the input. F of x is the result after the acts on the x. Let's go back to our ice cream example to understand what this was. So ice cream rule was each ice cream costs $2. Well, naturally, the rule will be cost equals 2 times a number of ice creams. We write this in a function language, right? That's the most important part in here. So in function language, we will write this like this: f of x equals 2x. And that's writing the rule, where x is the number of ice creams, and then f of x will be the cost, total cost. So if you use this equation, you will be able to find any number of ice creams because we have a specific rule, and that's what makes it a function. And so if x is 3, then we will write f of 3 equals 2 times 3, which will equal 6. That just means that the output for input 3 is 6. Nothing magical happened. We just used a new label for the input. So students see f of x and think, oh no, this is harder math. But really, it's just sentence written in a symbols, writing side by side. Output when x equals 5. So let's go ahead and try another one. X is 5. That means we're buying 5 ice creams, right? X equals 5. And so we will write this, that f of 5 will equal, what is it? 2 times 5. And that will equal 10. Okay, so f of 5 equals 10, considering the rule that every ice cream costs $2. Remember that x is the input, and then f of x is the output, meaning the result. So remember, in our previous examples, we talked about y, right? Y being the output. So f of x is another way of writing the y. So the input and output, when it's a function, they have a rule. Let's go ahead and write that down so that when we have x, there should be a rule that connects to f of x. That arrow is the whole idea of a function. In the next video, we'll see f of x in a table and graphs, and you will recognize it instantly. But for now, all you need to remember is f of x is the output for the input x. So if you want to practice, here's a few examples for you. What is f of 2 and what is f of 0 when the rule is f of x equals 3x? Please write your answers in the comments below. Thank you for watching, and remember, learning math takes patience, practice, and perseverance. See you on the next one.